All right, let's talk about rounding for addition and subtraction. So how do you round for sig figs when it comes to addition and subtraction? And the answer is, well, the answer begins here. You need to count the number of decimal places, not the number of significant figures. Number of decimal places determines how you round. So, consider this example. Notice how the numbers are lined up. Tenths place, hundredths place, thousands place, whole number, tens. This would be red if I had a color printer, but you get the idea. This shows where we round, and how do we know where to put this arrow? How did we know to put the arrow here? Which number determines where it is the most exact, least exact number? It is the least exact number that determines where to put that arrow. That should be a space in between there, but you get the idea. So the least exact number determines where you put the arrow. For the most exact number, which is not this one, last significant digit furthest to the left or furthest to the right. Well, let's look at this. The last significant digit determines whether it's most exact or least exact. For this number, it's this one. For this number, it's this one. For this number, this is the last significant figure. So for the most exact number, that's the one with the most decimal places. That's the last sig fig furthest to the right. For the least exact number, it's the one with the fewest decimal places. It's the one furthest to the left. So it's the one whose last significant digit is furthest to the left. In this case, it's this middle number here. Or rather, this 18.0. That's what I mean by middle number. And this number is least exact because, not because it's in the middle, but because it has its last sig fig furthest to the left out of the three of these. The red arrow should be drawn through the last sig fig of the least exact number. So because this is the least exact number, the arrow goes through its last significant figure. That's why this arrow is here. So least exact number, you put an arrow through its final significant figure. So make sure you do what it says here. So you're going to do this, and then you do this, you come up with the arrow, then you know it tells you you're going to round here. So when you round here, the 0 is next to 2, so it stays as a 0. And then you box it because it's your final answer. So make sure to write in all caps, I will always box the answer for every calculation. Yes, write this part in all capital letters here on the blank. Because answer's not boxed, do and do get reduced or no credit. Because then how do we know which one's your right answer? If you didn't box this one, how would we know? So anyway, having mentioned that, let's move on to this. So it wants you to go through the same kind of thing. 68.42, 19.105, 9.001450. Stack them up so that they're all decimals in the same places. And then we're subtracting them all. So it's that minus that minus that. And then 68.42 minus 19.105, oops, 5. And then minus 9.001450. And you get that number. So let's put that underneath here. 40.31355. Do we need to put the 0 here? It can't hurt because it's not the final answer. This is not the final answer. Anyway, what's that leave us with? Draw an arrow through them showing where you will round. Put an X here when you have done that. I'll grab a different color pen so I can do that. Hopefully this pen isn't dead. So where are we going to round? Well, let's look at the last sig figs. Here. And I picked a pen that's dead. All right, we'll use a different color. So there, there, and there. These are where we have our last significant figures. So we pick the one where the last sig fig is furthest to the left, and that determines that we round right here to the hundredths place, because all these go beyond the hundredths place. So this is the least exact one because it only goes to hundredths place, so we're going to round to hundredths place. Or put another way, we round here at this 1. The way now that I've done that, I'll put the little X there to show I've complied with the instructions. And if we're going to round here, and we've done, so we're going to do that, okay. Notice we've done the unrounded number, just like in number 2, and we've done that. Now round it to the decimal place that the arrow is pointing to and write the final rounded number next to it, just like in the example number 2. So an arrow pointing to the final answer. Okay. Arrow and then 40.31 because we round right here and that one is next to a 3. So we're going to do that, and then I will box that as the final answer. So write the final rounded answer, put an X here, put a box around it, put an X here when you have done that. Okay, there we go. So that would be your final rounded answer, how you go about doing that. This is how you show your work for addition and subtraction. Both addition and subtraction, you got to show your work in this similar kind of way. Okay, so remember to use scientific notation when your answer is very large or very small. Scientific notation must be used when any number greater than or equal to 1,000 and less than 0.1. If in doubt, just use scientific notation for everything. You'll never lose points for using it, but you may lose points if you don't. All right, so we got to go through these and look at what the answers would be. 4.89 minus 7.34. Subtract it out. Negative 2.45. Now, in this case, last sig fig here, last sig fig here, you round right here at the end. And in other words, what you're given doesn't change. It's just negative 2.45 is your answer. So just because you round sometimes doesn't mean you round every single time. You got to look at the data you work with. Once again, 0.051678 minus 0.01445. 0.51678 minus 0.01445 is that. All right, I didn't do a very good job of lining these up, but one gets the idea. Last sig fig here, last sig fig here. You got it round in this location, round at that 2 right there. So we're going to have 0.03723, and the reason why it's a 3 is because that 2 rounds up because it's next to an 8. But we got to do this as scientific notation, so that becomes 3.723 times 10 to the, let's see, 1, 2, minus 2. Onward, 1.64 minus 0.64. Okay, your calculator is just going to call that 1. However, notice these both go to the hundreds place, so you got to call it 1.00, as in your answer needs to go to the hundreds place just like these go to have their last significant figure in the hundreds place. So if you're going to round here, yep, you got to make sure that's there, so 1.00 becomes the answer for that one. Now, 8.75 minus 2. Clearly, that's going to be 6.75 for your raw calculator answer. However, your last sig fig is here, last sig fig here. The one furthest to the left determines where you round, so you round here. So counterintuitively, instead of 6.75, your correct answer becomes rounded to right here, this location. That 6 next to 7, it rounds up to become a 7. So this means 8.75 minus something in the roundabout area of 2 becomes something in the roundabout area of 7-ish, because this is kind of close to 9, so minus roughly 2 becomes roughly 7. All right, anyway. Let's look at some more. 764,518 minus, make that a proper comma, 200. Gotta want to line up the correct decimal places. That's going to be 764,318 for your raw calculator output. However, last sig fig here, last sig fig here, so we round right here to the nearest 100, because there's no decimal, so the last sig fig is this 2. So we round right here, which means 764,000 becomes 764,300. Or rather, 764,318 becomes 764,300. And then because that's way too big to write as just a regular number, we got to change that to scientific notation. 7.64 times 10 to the, 7.643 times 10 to the power of, let's see, 1, 2, 3, 4, 5. So 7.643 times 10 to the 5th. All right, onward. 489,060 plus 714.85 plus 24,514.9. And you add them all up. Oops. And you get that for your raw calculator output. So let's put that on there. 514,289.75. Note, I'm keeping all the decimal places lined up. And we'll underline our last sig fig. I'll go back to using a different color just because it's easier. Last sig fig is here, here, and here. This last 0 is not significant because there's no decimal. Oh, sorry, I take that back. There is a decimal. I overlooked it. So, where's my whiteout? There it is. Let's fix that. Last sig fig is here at the nearest whole number. This is the one furthest to the left regardless. So we do our rounding right here, which means it's going to be 514,289. Oh, look, that goes... It's next to a 7, so this 9 has to round up, which forces this up too. So this is almost like 289 becomes 290 with the decimal point right there. And then if we're going to make that scientific notation, that's 5.14290 times 10 to the power of, let's see, 1, 2, 3, 4, 5. There we go, rounded correctly. Next, 9.85 plus, oh, I wrote that a little prematurely, 756, so 756 plus 24.69. Trying to keep all the decimal places lined up. It's all a plus right there. We add it all up. And what does that come out to? 9.85 plus 756 plus 24.69. Raw answer is 790.54. And then if that's how we're going to be doing it, last sig fig is this one, and this one. This one's first to the left, so we round here at the 790. The 790 is next to a 5, so it becomes 791. And we could leave that as our final answer, or you could call it 7.91 times 10 to the second if you wish to put that in scientific notation. 10 plus 6. Yes, you would be tempted to say 16, all right, but your last sig fig is here and here, which means, because this is not a significant figure due to the absence of a decimal, you got to round it right here. And 16, well, that 1 is next to a 6, so it rounds up to a 2, so it rounds up to 20. That's right, 10 plus 6 is 20. But that means something roughly in the area of 10 or 20 or 0, somewhere in there, plus 6. Means it's going to be more than 10, maybe 20-ish. Okay, it just has to do with a lack of precision. All right, here, 4.5690 minus 9.5690 equals minus -5. Okay, now something to point out about that. If you put -5 for the answer, it's not right because, check it out, your last sig fig in each case is here at the end, which means you want to round to this decimal place. But you don't have anything there, so guess what? You're going to add it. 1, 2, 3, 4 zeros, because it's 4 decimal places back, so 4 zeros, which means this becomes your final answer. -5.0000. Okay, next, 456 million plus 20,000. Well, let's start with first of all, it's going to be 456 million, 0 to 0. Where to round? Yeah. Let's see. Last sig fig is here, but up here the last sig fig is way back here due to the absence of decimals. None of these are significant. So I was going to put a 0 on here, or a 0.0, but it doesn't really matter because you're rounding here. And that 6 is next to a 0, so that 6 stays a 6, so it becomes 456. In other words, 456 million. The same number you started with, that's what you get. Because it's 456 million plus or minus a million, and you add something that's so close to, it's so much smaller, it doesn't really change anything, that it doesn't really change the overall size of the number. So this becomes 4.56 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 4.56 times 10 to the 8th power. All right. Now, this looks the same question, but it's not. This has a decimal and this one doesn't. So 456 million. This is known for sure to be exact to the nearest whole number, whereas this is plus or minus a million. And then you add to that 20,000.0, and you get the same raw calculator output again, 456 million, 20,000. And, well, where do you round? Last sig fig for the top number is here, last sig fig for the bottom number is here, so we round here to the nearest whole number, which means 456,020,000 with a decimal point at the end. Convert that to scientific notation, that's 4.56020,000 times 10 to the 8th power. In other words, this is a far more precise measurement, giving him far more precise final result. Okay, onward. 45.0 plus 21.999. Add them up. I'll do it here for clarity's sake. It's 66.999, but nonetheless, I'd want you to see it. So 66.999. And once again, we underline our last sig fig here and here, which means you're going to round here. We're going to round to that 9 right there. That 9 is next to a 9, so it goes up. But if this 9 goes up, it turns into a 0, but it also pushes this one up. So it's going to turn it into 67.0. That would be our final answer. Again, because if you're rounding this 9 up, because it's next to a 9, so this 9 goes up, it becomes a 10, which means a 0 here, and then adding 1 to this number, which becomes a 7. All right, so that's that. Here, 485 plus 14.999, that is going to be 485, basically 500, but I'll show you nonetheless. Okay, see that? 499.99. 499.999. But remember how we round. Least exact number forces us to round where its last sig fig is, which means right here. So this is why I said it's basically 500, because if we're going to round right here, this 9 is next to a 9, so it goes up. But if this goes up, then this forces this one to go up. And if this one goes up, this forces this one to go up. So as a chain reaction, that leads to it rounded to basically 500. But you can't just put 500. The last sig fig is here, so we got to put a decimal to make this last place significant. 500 with a decimal. Again, because if you round this one up, then this becomes a 0 and forces this one up. If you round this one up, then it becomes 0 and forces this one up, and this rounds up to 5. Okay, onward. 0.003457. Oops, that is not a very clear 5. One gets the idea. Minus 1. So the answer is negative 0.9965. 0.9965. I'm just trying to make sure the decimal points are lined up. 428. Just making sure the decimal places are lined up. Yes. Okay. And once again, last sig fig, last sig fig. This is least exact. We round here, and this 0 is next to a 9. So guess what? It becomes a minus 1. All right. Now here, 9.310 times 10 to the negative second. 9.310 times 10 to the negative second. 1, 2. So 0.09310, or your calculator could have told you that. Oops. 0.0931. So 0.0931. Either way, 0.0931, and then minus 5.4 times 10 to the negative first. 5.4 times 10 to the negative first is 0.54, like that. So minus 0.54, 0.0931 minus 0.54 is negative 0.4469. Last sig fig on top is the 1. Last sig fig on bottom is this 4. We round here at this 4 right here, which becomes negative 0.45. Because the 4 is next to a 6, so it rounds up. All right, so that's that. Could this be expressed in scientific notation? Yeah, but because it's within this range, it's optional. But there's never any point penalty. You could totally put this as negative 4.5 times 10 to the negative first, and it's fine. Okay, 6.04 times 10 to the third is 6,040. But here, I'll prove it. 6,040. This is 906. I'll prove it. 906. And you're adding them. $6,946. And then we do our usual. Now you see how there's no 0, trailing 0 in the scientific notation? That means this 0 is not significant. If this is the last decimal in the scientific notation, then this is the last significant figure. Same here, last sig fig. So that means we round right here, because this is the last sig fig for this to the left, it's the least exact. Which means we round to 6,950, because this 4 is next to a 6, so it rounds up. Put as scientific notation, that's 6.95 times 10, oops, that's not a very good 10, times 10 to the third. There we go. 6.95 times 10 to the third. All right, well, there you go, ladies and gentlemen. That's how it's done.